Hello everyone. We want to talk about solving oblique triangles and learning about two new tools in trigonometry, two new laws, formulas known as sine law and cosine law. And we start with the sine law. Sine law is a formula like a over sine A equals b over sine B equals c over sine C, where A, B, C lowercase letters are representing the side lengths of the triangle, and capital letters A, B, C represent the angles in an oblique triangle. When we say oblique triangle, it could mean an acute triangle or an obtuse triangle, but never a right angle triangle. In the past, we have learned basic trigonometry. We have learned about SOHCAHTOA. We have learned about trigonometric ratios in a right angle triangle. But now we are dealing with situations where the angles are not right angle triangles, and SOHCAHTOA is not valid, and Pythagorean theorem is not valid, and we need new tools, new laws, new formulas to apply to do these kind of problems. And one of these laws is called sine law. And as I said, this is the formula. You can write these three ratios that are equal upside down as well. You can say sine A over A equals sine of angle B over side B equals sine of angle C over side C. You can write it that way as well. And this is valid in any kind of triangle, even right angle triangle. So here we have an example. We have a triangle, which is not a right angle triangle, and two angles are given. One is 40 degrees, one is 60 degrees. And one side is given, this is the side opposite angle B, that is denoted by lowercase b, and we want to find the length of side C. And because we can't use SOHCAHTOA, because this is not a right angle triangle, so we have only this tool to use, sine law. So we're going to say A over sine A equals B over sine B equals C over sine C. So we always start by writing the formula down. That's step one. And then we see that we have angle B, side B. So we have this middle ratio. And we have angle C, but we don't have side C. And angle A and side A, which is here, we don't even want to find. The question is not asking for that. So among these three ratios, we will be using the second and the third one. If they were asking for side A, then we would use this first ratio. So we have to see, depending on the situation, we will use either the second and third ratios, or the first and second, or maybe the first and the third one. So here we go 32, that's value of B over sine of 60 degrees equals C, which is the unknown, over sine of 40 degrees. Okay, we just substitute. So step one, you write the formulas down. Step two, you substitute the numbers. Step three, we have to solve this proportion. How do you solve proportions? The best and fastest and easiest way is to cross multiply. So we go 32 times sine of 40 equals C times sine of 60 degrees. Okay, and now we have to solve for side C. So how do we do that? We have to divide both sides of the equation by sine of 60 degrees. That's what we would normally do. So sine of 60, roughly it's 0.86, divided by itself would be just 1. So these two basically cancel out each other. So we end up with C on the right-hand side, and that's exactly what we were trying to find. And on the left side, we have 32 times sine of 40 over sine of 60, which we need to use a calculator and find out what the answer will be. So if you use a calculator, the answer will be roughly, approximately 24 centimeters. The unit of measurement is mentioned in the diagram, so we have to mention it here. If it's not mentioned there, you just say units. So right now I have to put 24 centimeters, okay? So this is the length of side C we calculated, okay? How did we do this? We used the sine law. So what was given here? Two angles were given, and one non-contained side was given. When I say non-contained side, it means that it's not side A given, okay? All right, so we have another example here. And in this diagram, first of all, it says solve triangle ABC. We have talked about the meaning of solving a triangle in the past. It means we have to find everything, all three sides, all three angles. So we have to find many things here. But here, two sides and one non-contained angle are given. If angle A was given, then that would be two sides and one contained angle. But right now, angle B is given. Sometimes angle C is given. So these are non-contained angles. That's what we mean. So if you have two sides and one non-contained angle, once again, we can use sine law. So I'm going to construct the chart that we used to have in the past. It's an organized way of solving triangles. So I write all the three sides and three angles. So we know that side C is 35. We know side B is 50. Side A we don't know. We need to find it. Angle C we don't know. Angle B is 60 degrees. And the rest we have to find. So this is an organized way of solving the triangle. It helps us to keep track of what sides, what angles are found, what sides or angles are yet to be found. So it's a good way of keeping track of things. So I'm going to use sine law here again. So I'm going to go B over sine of B equals C over sine of C. As you see, I have two sides, B and C. The numerators are known. And angle B, also we know it's 60 degrees. So we can easily find the measure of angle C. So step one, as I said, formula. We write the formula down. Step two, substitution. So we go 50 divided by sine of 60 equals 35 over sine of C. So cross multiplication again. 35 sine of 60. And then we have to divide both sides by 50, right? To solve for sine of angle C. So divide left side and right side by 50. Okay. So we get sine of angle C equals 35 sine of 60 over 50. So again, we need to use a calculator very carefully to see what this answer will be. And then I think I have a calculator. So 35 times sine of 60 divided by 50. So I got 0.6062. So 0.6062, 62, yes. And angle C would be the inverse sine of this decimal number. So on the calculator, you have to press the shift button or the inverse key. So we need to find the inverse sine of what we got, and the answer will be 37.3 degrees. 37.3 degrees. We normally round off to the nearest degree. So this is, I would say, roughly, this is approximately equal to 37 degrees. So now I'm going to include it in my chart. So now I have angle C. I found it, it's 37. Angle B was given from before, and now I can find angle A easily. So I go angle A equals 180, take away angle B, take away angle C. So that is 60 and 37. All right, because we know that the sum of the interior angles of any triangle is 180 degrees. So if you have two angles, one is 60, one is 37, you add them up and subtract it from 180, and that gives you the measure of angle A, the remaining third angle. So if you do the calculation, you get 83 degrees. So angle A is 83 degrees. And I will immediately include it in my chart before I forget. Now I'm looking at my chart. I see that all the three angles are found, but I cannot claim that the triangle is solved yet. So I still have to find side A. And in order to find side A, I have to use sine law again. So I go A over sine A equals. Now I can either write B over sine B or I can write C over sine C. Both are correct because we know the sine law. All three ratios are equal. But because angle B and side B are given, and when something is given, it's never wrong. So it is better to use the ratio B over sine B. Although I could have used C over sine C, nothing is wrong with that. But God forbid if I have made a mistake in finding angle C, and angle C is wrong, then in that case, I'm using a wrong value to find another wrong value. So in order to prevent something like this happening, which is common sense actually, it is better to always use the given values, which are never wrong. So I'm going to use B over sine B instead of sine over C. Okay. So we have A, which we don't know. Sine of angle A is sine of 83. B was 50. And angle B was given to be 60 degrees. Okay. So A would be 50 times sine of 83 divided by sine of 60. We need a calculator again. 50 times sine 83 divided by sine of 60. We have to be very careful with the closed brackets, open brackets on the calculator. And yes, I got 57.3. I hope you got the same answer. 57.3. For the side lengths, we can round to the nearest tenth of a unit, but for the angles, we may round to the nearest degree. So here I can write 57.3 units, of course. Okay. If it says meters or kilometers or centimeters, I'm going to write the unit. If it doesn't say any unit in the diagram, I just say units. And right now, when I'm looking at my chart, I see that I have found all three sides, all three angles. Everything about this triangle is known, it's clear. Therefore, I can claim that the triangle is solved. Hope that you understood the application of a sine law. And we're going to do some word problems later. And then there's one more law that we need to learn, and that's called cosine law, which will be explained in a separate lecture. Thank you for your attention.